Let's continue chapter 4, that is metals and non-metals. Today we are going to study the chemical properties of non-metals. The first chemical property of non-metals is the reaction with oxygen. Non-metals react with oxygen to form non-metal oxide. Here you can see the carbon reacts with the oxygen to form carbon dioxide. In the same way, sulfur burns in oxygen to form sulfur dioxide. So when sulfur dioxide gas is dissolved in water, sulfurous acid is formed. That is, SO2 reacts with H2O to form H2SO3, that is sulfurous acid. When sulfurous acid is tested with litmus paper, it turns blue litmus into red. Thus, we can conclude that non-metals produce acidic oxides. So here you can see the summary of the first chemical property of non-metal, that is the reaction of non-metal with oxygen, along with some examples of sulfur with oxygen and carbon with oxygen. So when non-metal react with oxygen, it gives non-metallic oxide, and these are acidic in nature. They can turn blue litmus to red. Next chemical property of non-metals is reaction with water. Non-metals do not react with water, but can be very reactive in air. Such type of non-metals are stored in water. For example, phosphorus is very reactive in air. If it is kept in air, it catches fire very easily. In order to protect phosphorus from catching fire in atmospheric oxygen, it is kept in water. Now, next property of non-metal is that non-metal do not react with dilute acids. However, they react with concentrated acid to form complex products. So the last property of non-metals is the reaction of non-metals with the bases. These are complex reactions, and we need to understand more about acids, bases and their reaction with the metals and non-metals. We have seen that some metals react vigorously, that is very fastly, with acids, whereas others do not. Accordingly, metals have been arranged in decreasing order of reactivity. Such a series is called reactivity series. So here you can see reactivity series of metal, in which in one column you can see elements like potassium, sodium, calcium, etc. and their symbols, like potassium is denoted by K, sodium is denoted by Na, and calcium is denoted by Ca. So the most reactive metal, potassium, is kept at the top of the series, and the least reactive metal, platinum, is kept at the last. Metals below hydrogen in the reactivity series do not react with dilute acids. They cannot replace hydrogen from an acid, as they are less reactive than hydrogen. Such metals such as copper, silver and gold react either with concentrated acids or do not show any reaction at all. So, in reactivity series, a metal can displace another metal which is lower in the series from its salt solution. Now let's come to the next topic, that is displacement reaction of metals. Here The more reactive metal displaces the less reactive metal from its salt solution, and this type of reaction is known as displacement reaction. So here you can see an example of displacement reaction of metals. Zn is the zinc and Cu is the copper, and CuSO4 is the copper sulfate solution. So when you will see the reactivity series, you will find out that zinc is placed a little higher than the copper. So zinc is more reactive than copper. So it displaces copper from copper sulfate solution and forms zinc sulfate solution, and the copper remains alone. So the color of the solution of the copper sulfate, which is blue, is changed into reddish brown color, that is of zinc sulfate. Similarly, magnesium is placed a little higher than the zinc. So magnesium is more reactive than zinc. So magnesium displaces zinc from zinc sulfate solution and forms magnesium sulfate, and the zinc remains alone. So this is all about displacement reaction of metals. I hope you must have understood the topic very well. Thank you and have a nice day.